Let's add another skill to our repertoire. We're going to be looking at the cosine rule. It's used to find unknown side lengths or angles in a triangle, and it's under the following circumstance. Either when we have two sides and an included angle, or if we have three sides and we're trying to find an angle. So this is distinct from the sine rule when you needed those matching side angle pairs. Let's have a look at the proof for this. So for this proof, it starts very similarly to the past proof, where we put in a height h here that's perpendicular to the length AC that we've got here. But we are, instead of using some trigonometry like you used for the last one, using sine of SOHCAHTOA fame, we're going to be using a little bit of Pythagoras. So if we call the length AD x, rather than calling the length DC y, let's just call that b minus x, because b is that length AC. It just avoids us having to use like AD and AC in our calculations a little bit later. It just gives us, fewer variables to deal with. So for the first right-angled triangle here, we'd be able to say that c squared equals h squared plus. Okay, so equating those two, we've got this equation, h squared is equal to this equation, h squared is equal to. So equating 1 and 2 becomes c squared minus x squared equals a squared minus b minus x squared. All squared, I should say. Let's algebraically expand out that b minus x squared, and eventually we're going to want to remove that x from our formula. We want our final formula to just be in terms of a, b, and c, the lengths of this triangle. So we'll expand that out, and then we're going to have to use a little bit of trigonometry finally to remove that x. My apologies, I had to pause because Evie decided to bark out the window. Let's continue expanding this out. So minus b squared plus now 2bx minus x squared. Okay, great. Well, at the barest of minimums, we can cancel off these x squareds, but we still have the problem of this x. So we are going to have to look at the purple triangle that I've drawn here. And the reason is because I know that's the triangle that we want, but I notice if we do, now I just need a little more room here, if we do cosine theta, well, this is the law of cosines, and we need a cosine in here at some point. And I'm cheating a little bit because I know where this proof is going, but once you see what happens, I think you'll like it. So looking at that triangle, the adjacent side is our x, the hypotenuse was c, and the cos of the angle is going to be cos A. So when we rearrange this, oh great, now we have x in terms of c times cos A, which is great because now we only have it in terms of the side lengths of our triangle and the angles in our triangle. So when we combine this and what we just did before, and I've just written it down there so that we had a record, let's replace that x with c cos A. So we're going to get c squared equals a squared minus b squared plus 2b c cos A. Now, this isn't traditionally how this equation is written. Traditionally, if we had this angle A, we want it to be with a squared as the subject, so a squared by itself. So if we move these over to the other side, I'm just going to do a little flipperoo, a squared is going to be b squared plus c squared minus 2bc cos, cos A. So that's our cosine rule. That's one way of writing it. When you want to find the value of a squared, then that's take the value of b, square it, c squared, and take away 2bc cos A. Now, this is just in terms of a squared. There's multiple versions of this formula. We could have written it in terms of b squared at the front. If it's b squared, instead of b squared plus c squared here, we're going to have a squared plus c squared minus, and now I imagine that this letter here and this letter here sort of jump over here without the square. So that becomes ac cos, and then this angle here needs to be the angle associated with this side, so cos b. And the final version of this formula, c squared equals, let's see if you can fill in the gaps now. Hopefully you've paused and had to think about it. Becomes a squared plus b squared minus 2, we need a and b now, ab, cos of c. Now, hopefully this final version of the formula reminds you of something. C squared equals a squared plus b squared. Well, a special case of this, if we found that C was 90 degrees in a particular triangle we were working with, well, cos of 90 degrees, maybe you remember, is 0. So that means this term would go away. So it turns out that the cosine rule is just a specialized version of Pythagoras' theorem, which I think is really, really neat. So the cosine rule, you can imagine this to be the general version. So let's write that, general version of Pythagoras' theorem, which I think is really neat. And if I were there with you in class, I would be jumping up and down because I think it's really, really cool. Okay, so let's do some examples. Okay, in this example here, we want to find the smallest angle in a triangle with sides 4, 7, and 9 centimeters. Let's just do a little sketch of this. I'm just going to draw a random triangle, perfect freehand, 4 centimeters, we'll make that 7 centimeters and 9 centimeters. Hopefully you can remember from some of the work that you've done so far is that the largest angle will need to be the side that's opposite, the angle that's opposite the largest side. So if I call this A, B, and C, then this would be, little a would be 4, little b would be 9, and little c would be 7. Hopefully you recognize, well, given that B is 9 centimeters and that is our largest side, then angle B needs to be our largest angle. So we need to use the cosine rule for this. And my thought is I want the version that has a cos B. So we could start by writing B squared, because we know eventually we're going to have a cos B at the end. That's going to be equal to A squared minus C squared minus 2AC cos B. Awesome. Cos B sounds funny. All right, now the lettering is arbitrary. This formula just represents an idea. One side squared equals, I've made a mistake, that should be a plus. The two other sides squared added to each other minus 2AC, those two other sides, cos of whatever angle is associated with the side length you've got there. Now, I don't remember the next version of this formula off by heart. I just remember this, and then I derived the other one. I want to find this in terms of cos B. So straight off the bat, hopefully you recognize I could write that as, add this over to the other side and subtract the B squared. We could have 2AC cos B equals A squared plus C squared minus B squared. So that would then give the value of cos B to be A squared plus C squared minus B squared all on 2AC. Now please don't forget, to find the final value of B, you'd need to do the inverse cosine of this. So if you wanted to jump straight to this, that's fine with me. I still think it's nice to write the formula first, especially for the sine rule, because it can be a little bit intense. Okay, now that I have everything in frame, let's actually substitute in what we've got there. So B is going to be equal to inverse cos still. We're going to write in A squared is 4 squared, because we said our value A was 4, plus C squared is 7 squared, minus B squared, 9 squared. If you ever come up with an error with this, you've probably written this bit in correctly. If you accidentally did it around the wrong way, if you had like, I don't know, a negative value in there, you'd get something a little bit strange. So that's just something to keep in mind. So just double check. A was 4, C was 7, B was 9. Great. And then on 2 times the value of A was 4 times the value of C was 7. Let's pop that into the calculator. Okay, I'm just double checking my signs there. I've got my calculator in decimal and it's in degrees because I do want this as an answer in degrees at the moment. So let's go. Okay, so that's 106.6. We'll do it to 1 decimal place. Degrees. Okay, awesome. Now, reading the question again, it says I also want you to find it in degrees and minutes, just so I can show you this once. So let's get our calculator back up again. So in order to do this, we need to go to keyboard, and you'll notice in Math 1 it says to DMS, that's degrees, minutes, seconds. We can just put that in. Oops, not a plus sign. We'll execute it. So this could also be written as 106 degrees, 35, 1 dash means minutes, and then 5.578, blah, blah, blah. 2 dashes means seconds there. So if I round that, that decimal portion is still acting like a decimal, so that would be 106 degrees, 36 minutes, and 6 seconds. So to be clear, this is how I want your answer most of the time. This is just in case I ever ask you, or in future if you're ever asked for minutes and seconds. But I'm going to be honest, I don't ask for it very often. Now I thought I was done, but I had one more example that I forgot to do here. In this example, we have two sides and the included angle. So in the example we had before, we had 3 sides and we found an angle. This example, we had 2 sides and an included angle. So this is an excellent time to use the cosine rule. B is our needed form here, so we're going to write the b squared form. B squared equals a squared plus c squared minus 2ac cos of b. I'm not going to finish this example. What I'm going to do is I'm going to make this a question for you to do, and I'm going to see how you go. But you're basically substituting into this question carefully, making sure your calculator is in degrees.